And welcome back to the morning show. It's Wednesday, Wise Guy time, and today we are live on location at Matt Stellan, our U of I physics professor's playing grounds. We're at the Loomis Labs here on campus in Urbana. Matt, today we're talking about gravity, and you have water in that cup, and I'm kind of nervous.
I do. Now, remember the last week we dropped a watermelon off the roof of the studio, and we saw actually, because we dropped an egg at the same time, maybe people didn't catch it, but they fell at the same rate. And the idea here is that everything accelerates downwards at the same rate of acceleration due to gravity. If it's something light or if it's something heavy, it falls at the same rate. So what I have here is a styrofoam cup, which is very light and is full of water, which is pretty heavy, and a pencil. And if I poke a hole in this cup, you see that it starts to leak water. Okay, what I'm going to do is drop this cup and keep an eye on what that water does as the cup falls. Okay, now what you notice there was as the cup was falling, the water stopped leaking out of the little hole on the bottom, and the reason for that is that heavy water and the light styrofoam cup were accelerating downward at exactly the same rate of acceleration, which is 32 feet per second every second.
Right.
Okay, and so if you're falling at the same rate, that basically means you're in free fall, and that means that one thing is not falling faster than the other. Pardon me.
You're right.
I contrived to have the door of this cherry picker right against this thing, which is, okay, so anyways. And so one of the beauties of gravity that makes it easy to understand, yet is actually of deep fundamental importance, is that it makes everything accelerate at the same rate, okay? And here's another demonstration of this. Inside this glass tube, there is a blue feather, which you can see falling kind of slow, and then there's this white piece of lead, and it's just painted white so you can see it easier. And you'll see that the lead appears to fall down a lot faster than the feather does, but that's really just because of air resistance. And so what we can do here is we can suck all the air out of this thing. Okay, I'll put this down. I'll attach the sucker. It's a vacuum pump. Turn on the vacuum pump. Get all the air out of this thing. And it was things like this which eluded people for years, actually. People didn't quite have a good fundamental understanding of Newton's laws of motion because it was hard to imagine what it would be like without air, without friction, because that was not, you know, what everyday experience was all about. And so it took people a while to realize, to come to the conclusion that this is true. Now watch what happens now when I flip this thing over. Okay, do you see that? The feather falls at the same rate as the lead thing does, and you know, sometimes it rubs along the side and it's a little bit slower, but it certainly hustles down to the bottom real fast. There was a beautiful experiment that the astronauts did when they walked on the moon. They actually did this. They had a feather and a hammer, and they dropped them at the same time, and you could actually see on television that things fell at the same rate, because on the moon there's also no atmosphere.
Sure. All right, we got a minute left.
Okay, good. 1 minute left. I can do one more thing that you can do at home, and this is actually very important. You might want to stand back a little bit. I'm going to do this here. This demonstrates that that gravity acts the same on all objects, also independent of their motion. So in other words, if I drop this ball straight down, it takes the same amount of time for it to fall down and hit the ground as it does if I were to throw it horizontally very, very fast, or even shoot it out of a gun. Okay, so in other words, if you just drop a bullet at the same time as you shoot a bullet out of a gun horizontally, they will still hit the ground at the same time.
Really?
And you can do an experiment to prove this to yourself with this 2 tennis balls on a little on a stick and a tennis racket. What I'm going to do is whack this tennis ball that way, okay? That'll also whack this ruler out of the way, and that's going to let this ball fall straight down.
It's like a pool billiards trick.
Yeah, exactly. So it's probably going to hit you. But anyways, all right, so I'm going to give this thing a whack. Now, I could see it. It was a little hard for you guys to see it, but the one that fell straight down hit the ground at the very same time as the one that had been launched straight out that way. It hit the ground way over there, but at exactly the same time as this one did. That's something you can try at home, and it's really simple.
Very cool. All right, we're going to wrap things up. What are we going to do when we come back?
Okay, when we come back, we're going to use this ramp that's behind you right here to actually prove that things that accelerate with a constant acceleration, they speed up at a constant rate, and their position actually changes as the square of the time.
Okay, very good.
Okay.
More science and more gravity when we come back. Right now, let's go check a storm tracker weather on the 3 with Jennifer Ketchmark.